PTH is the main hormone involved in regulating your blood calcium levels. PTH is released when blood calcium levels begin to drop below normal, and its actions will return the blood calcium levels back to normal. The gland that releases PTH is the parathyroid gland. This gland is located on the posterior surface of the thyroid gland. It consists usually of 4 small clusters. There are 3 targets that I'm going to mention, and we'll look at the actions for these 3 targets. The first one will be the bones. PTH goes to the bones and stimulates the osteoclasts, increasing their activity. Recall that osteoclasts are bone cells that break down the matrix. Calcium is stored within the matrix. When the matrix of the bone is broken down, the calcium is released, and this will help increase blood calcium levels, returning it back to normal. A second target of PTH is the kidneys. PTH will do several things at the kidneys. It will increase calcium reabsorption by the principal cells in the kidneys, but it will also be involved in the last step of forming the active form of vitamin D, calcitrol. Calcitrol is required for the absorption of calcium across the GI tract. Calcitrol stimulates the mucosal cells to express transport proteins for calcium. In the absence of calcitrol, you cannot absorb calcium from your diet. Let's look at some imbalances.
We'll begin with hypocalcemia, which can lead to several different conditions.
One condition is a problem with coagulation or blood clotting. All 3 pathways of coagulation, the intrinsic, extrinsic, and common pathways, require calcium. Calcium is actually clotting factor number 4. In low calcium levels, clotting will not occur normally. Osteoporosis is a decrease in bone density. When blood calcium levels are low, recall PTH is released, stimulating the osteoclast to break down the bone matrix. This will lead to a decrease in bone density. Hypocalcemia can also increase sodium permeability in the neurons. The sodium channels involved in action potentials are influenced by calcium. Calcium decreases the sodium permeability. So in the absence of calcium, an increase in sodium permeability occurs. What this means is that it doesn't take as long to reach threshold. If threshold is reached much more quickly, then that means that action potentials will fire more often. If you increase the frequency of the action potentials stimulating skeletal muscles, the skeletal muscles may get to a point where they don't relax between stimuli. This is called tetany. Skeletal muscle tetany can be fatal when the diaphragm is in a sustained contracted state. Hypercalcemia will do just the opposite. By decreasing sodium permeability in the neurons, it will take longer to reach threshold. And this will lead to skeletal muscle weakness as well as cardiac arrhythmias. Let's take a look at pacemaker potentials in the heart. The rapid depolarization of a pacemaker potential is primarily due to an influx of calcium. Therefore, calcium levels are critical for heart rate. Hypercalcemia will lead to an increase in heart rate. This will be a positive chronotropic factor and an increase in contractility, which is a positive inotropic factor.